90% of what students learn through traditional memorization is forgotten within 1 week. Not 1 year. Not 1 month. 1 week. That single statistic should make every educator, every parent, and every student stop and ask a very uncomfortable question. If we are forgetting nearly everything we study within 7 days, what exactly is the point of the way we have been doing school for the last 200 years? In the next 10 minutes, you are going to discover why the human brain is fundamentally wired against rote memorization, what project-based learning actually is and why it produces dramatically different results, and the one insight that flips conventional education wisdom completely upside down. Most people assume that more studying equals more learning. The research says something very different. Stay with us, because what you are about to hear changes how you think about education forever. To understand why project-based learning works, we need to go back to the very roots of how humans have always learned. For most of human history, there were no classrooms, no textbooks, no standardized tests. A young person who wanted to learn how to build a shelter did not sit and memorize the properties of wood. They picked up an axe and started building. A person learning to hunt did not recite facts about animal behavior from a scroll. They went into the forest with an experienced elder and figured it out through doing. This is not a romantic idea about the past. This is simply how the human brain was designed to acquire and retain information. Learning happened through experience, through failure, through iteration, and through genuine need. The formal classroom model we recognize today became dominant during the Industrial Revolution. Factory owners needed workers who could follow instructions precisely, show up on time, and perform repetitive tasks efficiently. Schools were deliberately designed to mirror factories. Students sat in rows, a teacher delivered information from the front, and success was measured by how accurately a student could reproduce that information on a test. This system was not designed to produce creative thinkers or problem solvers. It was designed to produce compliant, predictable workers. The tragedy is that we are still largely running that same factory model in a world that now desperately needs creative thinkers and adaptive problem solvers. Here is the neuroscience that makes this impossible to ignore. When you passively receive information, your brain processes it at a surface level. The hippocampus, which is responsible for converting short-term memories into long-term storage, simply does not engage deeply enough to create durable neural pathways. But when you are actively solving a real problem, multiple regions of your brain activate simultaneously. You engage your prefrontal cortex for planning and decision-making. Your limbic system attaches emotional significance to the experience. Your motor cortex activates if you are physically building or creating something. The result is a memory trace that is dramatically stronger, more connected, and far more resistant to forgetting. This is not philosophy. This is measurable brain activity documented in peer-reviewed neuroscience research. Project-based learning, or PBL, is a structured educational approach where students gain knowledge and skills by working on real, complex projects over an extended period of time. Instead of learning about water quality by reading a textbook chapter, students actually test water samples from their local river and present findings to city council members. Instead of memorizing historical dates, students investigate a historical controversy and construct a documentary film arguing a specific position. The learning is embedded inside authentic, meaningful work. And the difference in outcomes is staggering. A landmark study published in the Journal of Educational Research found that students in project-based learning classrooms scored significantly higher on standardized assessments than their peers in traditional classrooms, even though PBL students spent far less time drilling test preparation content. But here's what nobody talks about. The standardized test gap was actually the least impressive finding. The real difference showed up in retention rates 6 months later, in the ability to transfer knowledge to new problems, and in student motivation and engagement scores. PBL students did not just learn more. They became fundamentally different kinds of learners. Consider what happens inside a real project-based learning environment. A group of 8th graders is tasked with designing a community garden for their school that maximizes food production within a limited budget. Suddenly, mathematics is not abstract. They are calculating area, working with ratios, and managing a real budget with real constraints. Science becomes immediate because they are studying soil composition, sunlight requirements, and plant biology to make decisions that actually matter. They are writing persuasive proposals, giving presentations to school administrators, and learning to collaborate under pressure. Every single academic discipline becomes a tool for solving a real problem, not an isolated subject to be endured and forgotten. The data behind PBL outcomes is remarkably consistent across different age groups, different subjects, and different socioeconomic contexts. A multi-year study conducted by Stanford University researchers followed students across multiple school districts and found that students who participated in project-based learning were 2 years ahead in science and civics achievement compared to students in traditional programs. 2 full years. That gap represents an extraordinary difference in what these young people are capable of understanding and doing. And critically, the benefits were not limited to high-achieving students. Students who had previously struggled in traditional classrooms often showed the most dramatic improvement under PBL approaches, largely because the work finally felt relevant to them. Engagement is a metric that traditional education has largely ignored, and that is a catastrophic mistake. Research from the Gallup Student Poll, which surveyed nearly 1 million students across the United States, found that student engagement drops dramatically and consistently from 5th grade through 12th grade. By high school, only 32% of students describe themselves as engaged in school. The rest are what researchers call not engaged or actively disengaged, meaning they are essentially sitting in classrooms performing the motions of learning without any genuine cognitive investment. Project-based learning interrupts this slide because it introduces the one ingredient that rote memorization systematically destroys: genuine purpose. But here is where the conversation gets genuinely counterintuitive. Many educators and parents worry that project-based learning is too soft, that it sacrifices academic rigor in favor of engagement. The evidence says exactly the opposite. PBL actually demands more cognitive effort from students, not less. When a student is building something real, they encounter genuine complexity and genuine uncertainty. They have to make decisions without a clear right answer. They have to revise their thinking when the evidence contradicts their assumptions. These are not lower-order thinking skills. These are the highest levels of Bloom's taxonomy, which is the foundational framework that educators use to categorize cognitive complexity. Traditional memorization lives almost entirely at the bottom of that taxonomy. Project-based learning operates near the top. The real-world implications of this shift in educational philosophy extend far beyond test scores. A 2021 report from the World Economic Forum identified the top skills that employers will most urgently need through the next decade: critical thinking, creativity, complex problem-solving, judgment and decision-making, and the ability to collaborate with diverse teams. These are precisely the skills that project-based learning builds systematically and that traditional memorization-based education largely ignores. We are preparing young people for a world that looks almost nothing like the factory floor that our current school system was designed to serve. The gap between what schools produce and what the modern world requires is not a minor misalignment. It is a fundamental mismatch. Schools and districts that have made the full transition to project-based learning report transformations that go beyond academics. Teacher retention improves because educators find the work more creative and meaningful. Student attendance rates increase because young people actually want to come to school. Parent engagement grows because families can see and understand what their children are building and creating. The ripple effects of changing how learning happens reach every dimension of a school community. This is not a small instructional tweak. It is a fundamentally different answer to the question of what school is actually for. The evidence is clear, the neuroscience is compelling, and the outcomes are measurable. Experience does not just beat memorization in test results. Before you go, if you learned something valuable today, hit that like button right now. Subscribe to Brain Boost Academy for a brand new video every single day. We will see you in the next one.